Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we have described the synthesis of naphthalene which is given by Howard. It is a very good synthesis. What he did, he has taken the starting material as a benzene, treated with a succinic anhydride in presence of Lewis acid catalyst. This is a well-known reaction that is called as a Friedel-Crafts acylation reaction. Means aromatic compound always undergoes as a electrophilic substitution reaction. So that type of the reaction generally smoothly occur over here, and the resulting compound we got over here as an intermediate, this one, and this carbonyl group we would convert into as a hydrocarbon. There is a one very good method which is known as Clemonson Reduction. Carbonyl group is smoothly reduced into as a hydrocarbon with the zinc amalgam ZnHg in presence of the HCl acidic medium. It gives the hydrocarbon, and when the proper intermediate we got here required as a cyclization, and that cyclization can be done with the help of HF, that is a hydrogen fluoride. Cyclization takes place and we will get the tetra known as an derivative. Once again, if you observe this structure, there is a carbonyl group. We want to convert this carbonyl group into as a hydrocarbon. Once again, you can use the Clemonson reduction, which will suitably convert the carbonyl group into as a hydrocarbon, and we will get the desired product. They got the desired product, that is a tetraline, and that tetraline once formed, it can be heated with selenium or palladium in presence of chalcone. Aromatization takes place and we will get the resulting product is a naphthalene. This is a very beautiful method which is described here, that is shown over here. So this, up to this we have seen yesterday. So today what we are going to discuss, today we are going to discuss about the reaction of the naphthalene. What are the reaction of naphthalene, that we are going to discuss right now. As we know that naphthalene is a aromatic compound. We know that aromatic character and the Huckel's rule, those organic compound obeys Huckel's rule are generally termed as a aromatic compound. So according to that we are getting that one. Now let us see a reaction of naphthalene. Reactions of naphthalene. Reaction of naphthalene. Reaction of naphthalene. Reaction of naphthalene means properties of, chemical properties of the naphthalene, one and the same thing. Naphthalene undergoes all typical electrophilic substitution reaction of an aromatic compound like halogenation, nitration, sulfonation, Friedel-Crafts reaction, and it also undergoes oxidation reduction reactions. Let us see, first one is a halogenation reaction. Naphthalene is more reactive than benzene, as we know that, and therefore halogenation does not require Lewis acid catalyst. Halogenation of naphthalene exclusively takes place at one position, that is a speciality of this halogenation reaction. Let us see, first one is a halogenation. Halogenation reaction. Halogenation reaction. During the introduction we already stated that naphthalene is more reactive than benzene, When benzene undergoes as a electrophilic substitution reaction, it requires Lewis acid. Without Lewis acid, the halogenation reaction does not take place, even though Friedel-Crafts acylation reaction also does not take place when there is no Lewis acid used. What the Lewis acid doing there? Levic acid generate the electrophile. That is a function of Lewis acid over there. And when they generate the electrophile, and that benzene itself as a nucleophilic in nature, it seeks the electrophilic species. When electrophilic and nucleophilic species come together, there is a formation of the bond, and once you got then the reaction takes place. That is a general idea about the reaction. And here, if you compare the reactivity between benzene and the naphthalene is a more reactive than the benzene, and therefore in a case of naphthalene there are number of pi electrons are greater, and therefore the reactivity of naphthalene is greater over the benzene. Another thing, whenever the halogenation carried out in control condition exclusively, the reaction takes place at one position only, and therefore we are getting the product here. Let us see. I am representing the structure of naphthalene. You can see the structure over here. This is a structure. When it is treated with Br2, it does not require Lewis catalyst because naphthalene is a more reactive over the benzene, and here exclusively we will get the reaction at one position. So bromine is coming at one position, and the side product is a HBr. This reaction is known as a halogenation, or you can call it as a bromination. The product which we got over here is a 1-bromobenzene, which is a product which we got here in case of the halogenation. Now let us see another example, that naphthalene is an aromatic compound. They undergoes as an electrophilic substitution reaction. After the halogenation, let us see as a nitration reaction. Nitration, in case of the nitration, naphthalene on nitration with a nitrating mixture, concentrated HNO3 and concentrated H2SO4 exclusively gives 1-nitronaphthalene. Let us see once again over here. Naphthalene, as we know that the structure of naphthalene, this way we have drawn structure over here, and as we know that nitration means concentrated HNO3 as well as concentrated H2SO4, and this is known as a nitrating mixture. Nitration reaction takes place, but at what position? There we know that in the naphthalene, alpha and beta, these are the two positions are present over there, but in case of nitration reaction, naphthalene exclusively gives at 1-nitronaphthalene as a major product. Similar to as a halogenation reaction, nitration also occurs at one position, and it gives rise to the product. The name of that product is this one. nitro group is introduced at one position, and the name of this compound is a 1-nitrobenzene. 1-nitrobenzene is the derivative we got here after that naphthalene, because starting material in this case also we have taken as a naphthalene. Here also it is a naphthalene, because we are discussing the reactions of naphthalene. Two reactions we have seen, we have looked so far. Now let us, in addition to that, 2-nitronaphthalene is never obtained by direct nitration of naphthalene, but is prepared by indirect method from 1-naphthylamine. Look at here. How do you prepare 2-nitronaphthal? You cannot prepare, you cannot introduce nitro group at beta position, means at 2 position you never get. There is no direct method available or known to introduce nitro group at beta position, but by indirect method we can introduce nitro group at second position. What is that? For that purpose, what you can do, you can take the starting material is a 1-naphthalene amine. So starting material for obtaining as a 2-nitronaphthal, one should take the starting material is a this one, NH2, which is known as a, what is this? This is a 1-naphthylamine. 1-naphthylamine. 1-naphthylamine is the starting material when it is treated with the nitrating mixture. What is that nitrating mixture? Do you know that? Here you can use as a dilute HNO3. Dilute HNO3. The nitration can take place at second position because it is a free available over here. So let's see here NH2 group, and here the NO2 group is introduced, that is a nitro group at 2 position. This is known as 2-nitro-1-naphthalene. 1-naphthalene. 1-naphthalene. 1-naphthylamine. 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 After that, what you can do? On this compound you can treat with NaNO2 in presence of HCl 0 to 5 degree centigrade, which is known as a diazonium. You can form as a diazotization. This is known as a diazotization, which is known as a diazotization. In diazotization, what happening? Amine group, aromatic amine, when treated with NaNO2 in presence of HCl, diazonium salt will be formed, and if you treat this diazonium, this reagent NaNO2 sodium nitrate in presence of HCl, the resulting compound is formed as a alcohol. Aliphatic compound gives you the alcohol, and aromatic compound gives you the diazonium form. So this is one of the classical method to distinguish or to identify whether the given compound is a aromatic amine or the aliphatic amine. If aromatic compound is present, it gives rise to as a diazonium salt, whereas when the aliphatic compound is present, it gives the alcohol. This is one of the classical method also for the preparation of alcohol using the amines, aliphatic amines only. So here what do you get? You are going to get the product. Let's see here. So you are going to get the product. Once again here it is a N2 plus Cl minus and nitro group remains intact. So other part of this organic molecule remains intact, only changes are occur on that functional group, and that's why it is called as a functional group. And now when this is treated with, when boiling with alcohol, when it is boiling with alcohol, boiling with alcohol, it gives rise to the compound, the resulting compound you will get over here, this one. Let's see, this is a compound you got over here, that is a 2-nitro naphthalene, 2-nitro naphthalene, that is a product which we got over here. So in this way we can carry out the reaction on the naphthalene, or this is the one of the best way to prepare 2-nitro or beta-nitro naphthalene in this manner. Now let us move on to the next reaction. So far we have seen two reactions. One is a halogenation followed by nitration. Now let's see the sulfonation. Third one is a sulfonation reaction. Sulfonation reaction. Now here naphthalene on sulfonation with concentrated H2SO4 at 80 degrees centigrade gives alpha naphthalene sulfonic acid, while at 160 degrees centigrade it gives beta naphthalene sulfonic acid. When the alpha isomer is heated at 160 degrees centigrade, it is converted into beta isomer. This shows that the beta isomer is more stable than alpha isomer, and sulfonation is a reversible reaction. So that is the conclusion, or we can draw from here. So one could be at a lower temperature, that will be the kinetically controlled reaction, and one we are getting which is a thermodynamically controlled reaction. Let us see, this is a structure which I am representing here. So one can remember, this is a structure of naphthalene, and we are discussing the sulfonation reaction. Generally the reagent used here is a concentrated H2SO4, which is a king of chemical, sulfuric acid. Now when it is heated at 80 degrees centigrade temperature, because it is a temperature dependent reaction, sulfonation on naphthalene, it is a temperature dependent reaction, that you should remember. It is a very important word. It is a temperature dependent reaction. When that reaction carried out at 80 degrees centigrade, the resulting compound formed will be this one. Let us see the reaction which we are getting here. We are getting SO3H. Alpha isomer, you can call it as a alpha naphthalene sulfonic acid. Alpha naphthalene alpha naphthalene sulfonic acid. Now when the temperature is raised, temperature is doubled, say 160 degrees centigrade, what is going to happen? The temperature is raised, you will end up with the product that is a beta isomer. Let's see here, this is a compound which we got over here. This one SO3H, which is known as beta naphthalene sulfonic acid. And now this reaction, when we are getting as a this product at lower temperature, this is known as kinetic controlled reaction. Kinetic control reaction, this one, and this would be the thermodynamically stable, thermodynamic control. This is a thermodynamic control. Remember, this is a kinetic control reaction. The reaction takes place at lower temperature, and this is the thermodynamic control. The reaction takes place at higher degree centigrade, near about as 160 degrees centigrade. And when this isomer heated at 160 degrees centigrade, it is going to convert into the beta naphthalene sulfonic acid. Alpha isomer is converted into as a beta isomer, and this reaction is a reversible reaction. So that one should remember over here. This is a thermodynamic control, and this will be the kinetic control. And now the fourth reaction, preparation of naphthols. Naphthols are prepared by fusion of sulfonic acid with alkali. So in this way we can prepare the naphthol. So that is the fourth reaction that we are going to discuss over here. Let's see that reaction also here. That is a fourth reaction, and which is preparation of naphthals, which is a preparation of naphthals. Naphthals are prepared by fusion of sulfonic acid with alkali. Just now we have seen in case of just now we have prepared the sulfonic alpha naphthalene sulfonic acid as well as beta naphthalene sulfonic acid. Now once you take the starting compound over here you can take the starting compound, which is, here I am writing SO3H, alpha naphthalene sulfonic acid, alpha naphthalene sulfonic acid, when it is treated with alkali, like here 2 sodium hydroxide at 200 degrees centigrade. What do you, not 2, here is a 300 degrees centigrade at high temperature. The compound or the intermediate form is this one that I am showing over here. Here will be O, Na, positive charge or negative charge on it, and when it is treated with dilute H2SO4 acidification takes place, and it gives rise to the product we are getting over here, this one. See this product, very nice product you are going to get. This is a OH, and this is nothing but as a alpha naphthol. Alpha naphthol, or we can say it is a one naphthol. One naphthol. Alpha naphthol, or you can say one naphthol. Now let us see second one. Second, beta naphthol. How would you prepare beta naphthol? Starting from this, let's see. This is a compound at beta position. This group is present, that is a sulfonic acid group, which is known as a beta naphthalene sulfonic acid. Beta naphthal sulfonic acid. Once again, it is treated with alkali like as a sodium hydroxide at 300 degrees centigrade. When it is treated with alkali like sodium hydroxide, the resulting product obtained would be this one, which I am representing here O, Na plus, that is a sodium salt of, which is a sodium salt of phenoxide ion, or here we not here at 2 position. So let me show this position O, Na plus and minus charge. This type of the sodium naphthoxide is formed, and when it is treated with dilute H2SO4, the resulting compound formed will be this one. This is a compound which you are going to get over here, OH, and this double bonds are there. This is nothing but as a beta naphthol, brown in color, beta naphthol, or you can say 2-naphthol, beta naphthol, or you can say it is a 2-naphthol. So in this way we have seen some of the reaction of the naphthol in the remaining reaction that we will discuss in our next lecture. Let us stop today here. Thank you. Have a nice day.